What if I tell you that the device you're using to watch this video might one day outsmart you? A thought-provoking question, isn't it? But let's take a step back and delve into the realm of artificial intelligence, a concept that has the potential to turn this hypothetical question into a reality. This video is your guide through the intriguing labyrinth of AI as we explore the 10 significant stages of its evolution. So buckle up and stay with me as we journey through the evolution of artificial intelligence. Our journey starts with handcrafting, the first stage of AI. In this stage, we see the inception of artificial intelligence, a time when every piece of knowledge that a computer had was meticulously and manually programmed by human hands. This era of AI was dominated by rules and algorithms, a time when machines were only as smart as the instructions they were given. Handcrafting set the foundation for what was to come. It was a time of discovery, exploration, and immense learning. It was a time when humans were trying to replicate their intelligence in machines, laying down the first bricks of what would become a colossal structure of artificial intelligence. This stage was significant because it marked the beginning of an era where machines could start to think and learn. However, it was limited as the machines were only able to function within the boundaries of the preset rules and algorithms. Handcrafting was not just about coding or programming, it was about envisioning a future where machines could be intelligent, where they could process information and make decisions. It was about dreaming of a world where machines could potentially outsmart us and then taking the first steps towards making that dream a reality. This was the first step towards creating intelligent machines. Following handcrafting, we entered the era of expert systems. So, what exactly are these expert systems? These are computerized entities designed to solve complex problems within a specialized domain that ordinarily requires human expertise. They're not your run-of-the-mill software. They're unique in their ability to replicate the decision-making ability of a human expert. The significance of expert systems in the evolution of artificial intelligence cannot be understated. They marked a major shift from the basic rule-based programs to more advanced systems capable of making informed decisions. They're built to understand, learn, and mimic the decision-making process of experts in various fields, from medicine to finance and even chess. This era saw machines not just follow instructions, but engage in problem-solving by applying logical rules and reasoning. It was a huge leap forward. It was the dawn of machines that could think, albeit in a very limited scope, but that was just the beginning. These expert systems, with their ability to make decisions based on a set of rules, paved the way for more complex AI systems. They set the stage for what was to come, an era where machines would not just think but learn. Expert systems paved the way for more complex AI systems. The third stage, machine learning, brought AI closer to mimicking human intelligence. Machine learning, or ML for short, is a game changer. It's a method of data analysis that automates the building of analytical models. The magic of ML is that it allows a system to learn from data, identify patterns, and make decisions with minimal human intervention. It's like teaching a child to identify an apple. You show them different apples and tell them this is an apple. After a few repetitions, the child learns to recognize an apple. That's how machine learning works. ML gave a whole new dimension to AI, enabling systems to learn and improve from experience. It meant computers could start to understand and learn from the vast amount of data they were processing. This ability brought us closer to creating systems that could mimic human intelligence and perform tasks that usually require human brainpower. ML was a giant leap forward in the AI journey. It was no longer about programming rules. It was now about providing data and algorithms to learn from that data. This shift in approach steered us into a new era of AI, where machines could improve and adapt by themselves. Machine learning marked a significant milestone in AI development. Next came deep learning, taking AI to new heights. Imagine a neural network, but not just any neural network. Picture one that's deep, with many layers, each learning to transform its input data into a slightly more abstract and composite representation. That's the essence of deep learning. Deep learning is a subfield of machine learning, but it's not just another technique. It's a revolutionary approach that's all about calculating the weights of the neurons in a neural network. And it's not just about size either. Deep learning is about depth, about complexity. It's the depth that allows patterns to be recognized in larger and larger contexts. This has had a profound impact on AI, enabling it to accomplish tasks that were previously thought impossible. From recognizing images and understanding natural language to driving cars and diagnosing diseases, deep learning has been at the forefront. It's been instrumental in the development of AI, pushing the boundaries of what's possible and challenging our understanding of intelligence. The beauty of deep learning is that it doesn't stop at mimicking human intelligence. It surpasses it, learning from vast amounts of data that a human brain could never process. It's this ability to learn and adapt that has made it a game changer in the field of AI. Deep learning brought us even closer to creating truly intelligent machines. The fifth stage, transfer learning, further enhanced AI capabilities. This transformative stage in artificial intelligence evolution took a leap from learning from scratch to leveraging pre-existing knowledge. Transfer learning is akin to a skilled chef who, already proficient at Italian cuisine, learns French cooking faster by applying his existing culinary skills. In AI terms, a model trained for one task is applied to a different but related task, reducing the need for extensive data and computational resources. This technique opened up new vistas in machine learning applications, particularly in areas where data is scarce. Imagine a scenario where a model trained to recognize cats is now tasked to identify dogs. With transfer learning, the model doesn't need to start from zero. It already knows what an animal looks like, and it just needs to fine-tune its knowledge. This approach helped to improve the efficiency and effectiveness of machine learning models, accelerating the pace of AI development. It's like giving a head start in a race to the finish line, and in our case, that finish line is the development of advanced AI. Transfer learning brought us one step closer to achieving advanced AI. The journey continued with unsupervised learning and reinforcement learning. Now, let's dive into these intriguing stages of AI evolution. Unsupervised learning is akin to a self-starter student. It's about algorithms identifying patterns and relationships in raw data, without any prior training. This unsupervised approach opened doors to more complex data interpretations, paving the way for more advanced AI capabilities. On the other hand, reinforcement learning is like a player in a game, learning to make moves based on rewards and penalties. The AI system learns to navigate an environment, making decisions that maximize a reward function. It's the backbone of systems that learn to play chess or drive cars autonomously. It's all about trial and error and learning from previous actions. Both unsupervised learning and reinforcement learning have made significant strides in AI's journey. They've helped machines better understand the world around them and make decisions in complex, uncertain environments. These stages set the stage for the final steps in AI development. The eighth stage, self-learning, marked a major leap in AI evolution. It's like a child learning to walk, then run, then sprint, all without any guidance. This stage is where AI begins to learn on its own, creating its own rules and improving itself without any human intervention. It's a fascinating and somewhat intimidating concept, isn't it? Imagine an AI system that can teach itself how to solve complex problems or develop new strategies for gameplay, all while learning from its own successes and failures. It's like having a super-intelligent, never-tiring, always evolving brain at your disposal. But it's not just about solving puzzles or playing games. Self-learning AI has far-reaching implications. It can lead to revolutionary advancements in numerous fields, from healthcare to finance, from climate change to space exploration. It can help us understand the mysteries of the universe or find solutions to some of our most pressing problems. However, it's not all sunshine and roses. With great power comes great responsibility. We need to ensure that these self-learning systems are designed and used ethically, responsibly, and for the benefit of all. Self-learning brought us to the doorstep of advanced AI. Autonomous AI, the ninth stage, brought us one step closer to achieving true AI. Autonomous AI is a type of artificial intelligence that can understand, learn, predict, and operate entirely on its own. It's like a child growing up, learning from its mistakes and making decisions based on its experiences. This kind of AI doesn't require any human intervention. It can perform tasks independently. Imagine a self-driving car navigating through city traffic, or a drone delivering your packages, all without any human help. This stage's significance lies in its ability to create systems that can adapt to new situations and solve problems that they were not specifically programmed for. It's like having a digital assistant that not only knows your schedule but can also predict your needs and make decisions on your behalf. The implications of this technology are vast. From autonomous vehicles to predictive healthcare, autonomous AI has the potential to revolutionize our lives, but it also raises ethical and safety concerns. These intelligent systems are making decisions, and we need to ensure they do so responsibly. Autonomous AI set the stage for the final stage of AI. The final stage, sentient AI, is the future we are striving for. Picture this: an AI with the ability to understand, experience, and respond to its environment as a human would. This isn't just about processing data or learning patterns, but about possessing consciousness, emotions, and self-awareness. We're talking about a future where AI can make decisions based on ethical considerations, experience joy, sadness, fear, and excitement. A future where AI isn't just a tool, but a being with a mind of its own. But this future is not without its challenges and implications. As we venture into this uncharted territory, we need to think about the ethical implications. How do we ensure that sentient AI is safe, that it respects human rights and values? Moreover, we need to ask ourselves, are we ready to share our world with sentient AI? Are we prepared for a future where our coworker, our friend, or even our companion could be an AI? Sentient AI is the pinnacle of AI evolution, a future that we are yet to achieve. So that's our journey through the 10 stages of AI, from handcrafting to sentient AI. Taking a step back, we began with handcrafting, where everything was manually programmed, giving birth to the earliest forms of AI. Then came the rise of expert systems, where rules-based systems became the norm, expanding the reach of AI into various industries. Following this, machine learning emerged, marking a shift from rule-based systems to models that could learn from data, sparking a revolution in the AI landscape. This led to the advent of deep learning, where neural networks began to mimic the human brain, bringing about unprecedented advances in AI capabilities. The dawn of transfer learning followed, allowing AI to apply knowledge from one domain to another, thereby reducing the amount of data needed for learning. This evolution continued with a shift from unsupervised learning to reinforcement learning, where AI systems learn to make decisions by interacting with their environment and learning from the consequences of their actions. As we moved on to self-learning AI, the systems began to learn without any human intervention, marking a significant milestone in AI evolution. This brought us to autonomous AI, where AI systems can operate independently, making decisions without human input. And now we're at the threshold of sentient AI, where AI systems are not just autonomous but also self-aware, capable of experiencing and understanding the world in the same way humans do. It's a breathtaking journey, isn't it? It's been an incredible ride through the evolution of AI, witnessing how it has transformed from simple rule-based systems to potentially sentient beings. As we stand on the brink of sentient AI, one can only wonder, what's next?